Dr. Hyman again. Here I'm going to show you how to use the master mix template calculator in Excel. So the first thing that I'm going to do is navigate to the course homepage. Go ahead and go to modules, navigate down to module 6, and download this master mix calculator template. Go ahead and download that. Open it up, and you should see something like this. Let me blow this up a little bit so you can see it better. So essentially what the spreadsheet is showing you is the volume of each major reaction component in one PCR reaction. So we're looking at PCR reactants, which is your DNTPs, some salt ions, your DNA polymerase, and for each reaction there's 15 microliters of that. Then we've got our forward and reverse primer mix. For each reaction we're going to have 1 microliter of that. We've got our H2O, so this is actually going to vary according to the amount of the other reagents and the size of the actual reaction that we have. Then you've got your DNA template, so we're adding in 2 microliters of DNA template for every 30 microliter total reaction volume. So that means when we're looking at your sort of PCR strip tube like you see in this image here, each of these tubes is going to have a total volume of 30 microliters in it. 28 microliters of that is coming from your master mix, and 2 microliters of that is coming from your DNA template. So basically all you're doing here is putting in adaptable formulas into each spot here where there's yellow. So for example, here to calculate the volume of water, it's the total reaction volume, which is 30, minus the volume of the PCR reactants, plus the primer volume, plus your DNA volume. So it's basically this, plus this, plus this. It's 30, which is your total reactant volume, minus this, plus this, plus this, to give you the total volume that's left over that needs to be water. So we're going to put in the equal sign, and then total reaction volume, so that's this. So we'll click on that cell, minus, open parentheses, this cell, plus this cell, plus this cell, close parentheses, and then I'm going to hit the return button. And so this is the volume of water that's going to go into each of those little tubes like you see right here. So we'll have 15 microliters of PCR reactants, 1 microliter of forward and reverse primers, 12 microliters of water, 2 microliters of DNA. And if you add that all together, it should add up to a total volume of 30 microliters. And if you do the math, it does. Okay, so the next part is entering the number of reactions. So in other words, how many total tubes, 1, 2, 3, 4, 5, 6, are you going to have in your master mixer? How many total tubes are you going to have, or how many total individual PCR reactions are you going to have? So in this case, we have 6, but remember, you always add about 10% more, so we're going to make enough for 7, or you should make enough for 7. So just for fun, I'm going to say that I'm doing 120 reactions. So you will not do this many, but I'm just going to say that for fun. So we know for each individual 30 microliter reaction that's going to happen in one of these tubes, we're going to need this volume of PCR reactants, this volume of primers, this volume of water, and this volume of DNA. So now the question is, for this master mix tube that we're mixing up here, that's going to have to be distributed to each of these individual reaction tubes, what's the total volume of each of those major components that we need to have to make enough master mix to fill up each of these individual tubes? So the way we go about figuring that out is using these blocks down here that says volume in master mix. So what's the total volume of PCR reactants that we need? So you can use this formula right here that basically says it's the volume of PCR reactants, which is this right here, times the total number of reactions right here, which is, in this case, 120. So to make this an adaptable formula, you hit equals, and then it's this cell, which is 15, and then you multiply that, so I put it in an asterisk, times 120, or this cell right here, or whatever I put in that cell. And then I hit the return button. And so this says I need 1,800 microliters of PCR reactants to have enough volume in my master mix to make 120 individual PCR reactions. So we can do the same thing here for primer mix. This equals the volume of primers that we're putting into each individual reaction times the total number of reactions, enter. So 120 of the primer mix. Let me drag this over here. And the total volume of water, this equals whatever we calculated here, times the total number of reactions is 120. Hit the enter button. And now we've got what volume, or the total volume, of each of the major components that we need to put into this master mix tube to be able to distribute 28 microliters into each of these individual tubes. So you guys are going to have to figure out what number you put in here for your total number of reactions. But the nice part about this is, let's say that I wanted to do 4 reactions. I can change that number, and look, all of these numbers automatically adapt to tell me what volume of PCR reagents, primer mix, and water I need to put into my master mix to have enough volume for 4 reactions. Let's say I want to do 20 reactions. Change it again. These equations automatically adapt. Same thing here. Let's say that I want to change the amount of template I put into 4 microliters of DNA template for whatever reason. If I hit the enter button there, the amount of water automatically changes, and you can see that down here, the total volume of water that I need to have automatically changes. And so by using those Excel equations, you have a nice little template where you can manipulate all these different numbers and have the equations automatically adapt to know what volume of each of these major PCR components you're putting into this master mix tube right here.